witness. Mighty God. Mighty God.
Human beings are the only intelligent species today. Our intelligence has kept us alive in an environment that is hostile to life by nature. And we will continue to thrive in this environment for many more thousands of years. But it seems that our future as a species does not depend so much on the process of natural selection anymore. We have developed civilizations, sciences, and technologies that for the first time in history enable us to manipulate our own nature. Far from the mechanisms that gave rise to our existence as a species, beyond the detailed developments that have brought us to our current stage of being, it is ourselves, mankind, who have the frightening option of deciding the destiny of our species. A tall build, an elongated skull, strong projecting cheekbones, a high forehead, a long narrow nose. This was what Cro-Magnon man looked like. He arrived in Europe between 50 and 100,000 years ago. He came from Africa. If we could bring one of them into the present, after teaching him all our knowledge and dressing him in our clothes, nobody would realize that he was a prehistoric man. Today, human beings are not so different from Cro-Magnons. We use language, we have burial rites, we make useful objects and symbols, and we have complex belief systems. We carry practically all of the very same genes. Making chiseled strokes in stone and writing on a keyboard are really just different stages in the same process. But what about 500 centuries from now? Would our presence among our future descendants go unnoticed as well? Natural evolution mechanisms need long periods of time to be effective. In the last 100,000 years, we have changed very little, but all of that could change overnight. Our cultures, our sciences, and our technology have altered the process of natural selection. In biological terms, survival is not reserved exclusively for the strongest. Our genes do not evolve towards differentiation. On the contrary, progress in communications has generated a constant crossbreeding of human beings with different origins. With every passing day, we are growing more and more similar to one another. Nature seems to have finished its work on us. And yet, evolution continues.
Until a few thousand years ago, evolution was governed exclusively by natural selection, including the early evolution of mankind. But now that we have acquired this very remarkable brain and have used this brain to study and to do research and to try to understand, now that we have achieved a considerable degree of understanding of life, now that with the help of this knowledge, we have built extremely powerful techniques to manipulate life. now that we cover the world with our own, well, first of all, with human beings, and also with our industries, with our agriculture, with all our activities, we have become the main, we have acquired the main responsibility for the future of life. Natural selection is still working, but basically we have in our hands the future of life, and this is a tremendous responsibility.
It seems as if nature has given us intelligence so as to abandon us all alone, face to face with the future. We have the means to genetically alter our own cells. We can duplicate human beings. We can make them taller, more handsome, or more intelligent. If such changes depended on natural selection, it would take 1 million years before the first results would appear. But we have the control, and we are able to change a person's traits even before he or she is born. Perhaps we could take a walk and go unnoticed in the world of 400 centuries in the future. But it might also be possible that our future descendants would find us as different from them as we would find the hominids who lived 1 million years ago. The fact is, we have the capacity to change. We simply have to decide if we want to. Everything depends on the interactions between these 100 billion neurons in the human brain, where intelligence seems to be located. Right now, there are more than 6 billion brains at work all over the planet, but each one of them is a world unto itself. However, at the same time, all of them are interconnected to the same network. They can communicate among themselves and become empowered by a common heritage. The human brain is where the yearning for survival is nurtured, where the curiosity that drives us to continue to develop and progress, to develop our creative abilities, is nurtured. This mass of neurons defines us as a species, even though in a physical or biological sense, it doesn't seem so different from the brain of an ape, our nearest relative.
It is not even clear what are the differences. It's clearly, again, our cortex is much more developed than the cortex of the apes, the neocortex. But very likely the difference is essentially a quantitative difference. It's not that we have something different from the apes. It's that we have more of the same. Okay, we have more neurons, we have more of neocortex, so we can do more things, more complex things than the ape can. But the basic tools, the basic pieces, they are the same. I don't think there are basic differences.
The development of the human brain was basically the result of the manual activities performed by early hominids. The brain facilitates the planning of actions, which serve in turn as methods of learning. The process began when our first ancestors developed the capacity to make and use tools. By walking erect, they were able to work with their hands in plain view. Thus, their brains could visualize more and more complex manual activities and then carry them out. The constant interaction of eyesight, hands, and tools over hundreds of thousands of years gave rise to the generation of new nerve connections. Tools became increasingly more sophisticated and the tasks to be carried out with them more and more difficult. The brain evolved, slowly but surely, into what it is today. Scientists have called this amazing process a dialogue between the hands and brain. Two and a half million years have gone by since hominids first created tools. This surely must be a record for developing an instrument as amazing as the human brain.
But let us say, when I look at all the constraints that have participated in the shaping of evolution, I come to the conclusion that whenever the conditions allow, there will be increase in complexity. And this has been going on for several billions of years. There has been evolution in the direction of complexity has been going on all the time, from prokaryotes to eukaryotic cells. And then when the eukaryotic cells started making the first plants and the first animals, those organisms were extremely simple. And then over hundreds of millions of years, they have progressively developed and evolved into beings of increasing complexity. Of course, we still have bacteria, we still have sponges, we still have the worms and organisms, but at the same time, there has been this evolution in the direction of complexity. And in the last 6 million years, there has been this tremendous step from chimpanzee-like primates to human beings. In 6 million years, the size of the brain has increased threefold. That's fantastically fast. Now, if we think that there is another maybe 5 billion years left for life on Earth, if this continues, I like to think that quite possibly 100 million years from today or 500 million years from today, there may be beings on Earth or elsewhere much more intelligent than you and me.
Indeed, time has left us enough evidence to be able to confirm that between these two images, there is a difference of some 6 million years. A period during which the powerful forces of natural selection have barely differentiated us by 1%. And yet, what will the next picture look like? Or better yet, when will it be taken? Natural selection suggests that chimpanzees are our nearest biological relatives. They share more similarities with us than orangutans or gorillas do. The careening history of human intelligence actually started with them. Chimpanzees use tools, show affection with kisses and caresses, and have developed a complex social communication system. They are able to feel and express their feelings. They learn from watching and imitate both gestures and movements. The anatomy of their brains and nervous systems is essentially the same as ours. They can be seen performing uncomplicated, yet intelligent operations once they have learned them. Individuals living in the wild constantly need to make decisions about which group to live in or when to use force. After all, they are hominids, just like us. DNA studies say it all. The chimpanzee genome is 99% identical to the human genome. Of course, there are also some major differences. The most relevant difference has to do with speech, an ability possessed exclusively by humans. This is one of the reasons for our scientific name, Homo sapiens sapiens, hominids considered intelligent twice over. It all began here, in the Rift Valley, a beautiful place in eastern Africa between Somalia, Kenya, and Ethiopia, a place known as the cradle of mankind. Up to now, this is the only area on the planet where we have found evidence of our earliest ancestors. Some 4.5 million years ago, there lived here relatively short people with huge teeth called Ardipithecus ramidus by paleontologists. They are probably our earliest ancestors, though many scientists differ on this question.
And I think that it is most likely that we haven't found it yet. Of all the candidates that we know, of all the as you say, many fossils have come in recently. But of all the possible candidates for the human ancestor, there's not one that I think is more likely than another. And I think it is most likely that we haven't yet found the ancestor, the real ancestor. Because in the fossil record, you never sample every single fossil that ever lived or every single species that ever lived. So it's very likely that we haven't yet found the right one. But we have to keep looking and maybe we find it.
Meave Leakey is heiress to a prolific paleontological saga closely linked for more than 3 generations to the history of man's evolution. In 1994, she surprised the world when she found the first fossil evidence of Australopithecus anamensis, a certain rival of the ramidus, for the title of earliest ancestor of present-day humans. The Australopithecus anamensis lived some 4 million years ago on the eastern shore of Lake Turkana in Kenya. Its anatomy suggests certain evolutionary progress inherited from its predecessors, but it does not really differ all that much from the ramidus. According to reports written by Leakey after her finding, the anamensis still had a dental apparatus similar to an ape's, but the back of the skull had increased slightly in size. From the shin bones, Leakey deduced that her hominid was a biped, a trait it shared with the other predominant species in the world over the following 1 million years, the Australopithecus afarensis. Lucy is undoubtedly the most famous Australopithecus afarensis in the world. She looked like this. Female, she was over 1 meter tall. She lived 3,200,000 years ago around Hadar, Ethiopia. Her name comes from the Beatles' pop song, Lucy in the Sky with Diamonds, a favorite among the paleontologists that discovered her skeleton in November of 1974. Lucy's finding finally confirmed bipedism in hominids.
When we look at the fossil record that we have of our ancestors, there's a big group known as the Australopithecines, and they are usually considered to be the ancestral type of, and possibly one of the Australopithecines would be an ancestor for later hominids. And Australopithecus afarensis has always been considered to be the common ancestor of all the diversity that you see later. But I think maybe the Australopithecines were possibly an early group that in fact didn't go anywhere, and maybe again we haven't found the group that actually represents the ancestors of ourselves. And as I say, we sample such a small sample in the fossil record. We don't have everything that ever exists. And I think the more that we find, the more we will realize that there are other possibilities out there. And so I wouldn't like to say myself what is the direct ancestor, which of these is the most likely. The Australopithecines are more likely than the Paranthropines, for example. But it's not clear that Australopithecus is ancestral to Homo even, or even where Homo came from. And so I think we just don't know at the present time. And if you look back into when you get to Ardipithecus ramidus, or Orarin tugenensis, or any of these early forms, Anamensis, Afarensis, we simply cannot say. So when somebody asks me to draw a family tree, I say, no, I won't do that. Because if you draw a family tree with lines going from one to the other, you're implying that you know something that you actually don't know. And so I say that this group looks like this looks like this, but we don't know which group went to us. We just don't know.
There are certainly a lot of unresolved challenges in this area, but since we are human beings, we won't be able to resist the temptation of investigating and learning all about the details of our genealogy, even if it is no simple matter, given the scant information we have at our disposal. Why did we become human beings? And more importantly, how did we become human beings? It's possible that it was all just a big coincidence. But we know that we exist thanks to a detailed evolutionary process that started with Australopithecus over 4 million years ago. Our runty ancestor with ape-like teeth began the revolutionary practice of walking upright. And because of this, they freed their hands, and in the bargain established favorably appropriate conditions for the rapid development of their brains. The rapid development of the brain established a qualitative difference between this species and other earlier hominids. Though the volume of this brain wasn't even half of a present-day human brain, the difference was enough to mark the moment when Australopithecus took the step towards becoming another genus, the Homo genus, to which humans belong. What made these beings more human was that they made frequent and precise use of stone tools. Hominids began to use primitive tools some 2.5 million years ago. The skillful Homo habilis was the only one of them to survive. All the other hominid species disappeared somewhere along the winding paths of evolution. By about 1,700,000 years ago, Homo habilis had evolved enough to merit another name, Homo erectus. They received this name because when they were found, paleontologists thought they were the first to walk erect. At some point in time, this skillful hominid who made tools, walked upright, and probably competed against and put an end to all the other intelligent species in existence then, decided to leave Africa and conquer the world. Human beings discovered the concept of migration some 2 million years ago. The adaptive success of Homo erectus resulted in its expanding little by little until they had occupied the entire expanse of their original habitat. Then they covered northeastern Africa and eventually populated what is the present-day Near East. It wasn't long before they spread towards Asia. Fossils and tools have been found in such faraway places as China, the island of Java, and of course Europe. In all these places, there were evolutionary lines that were more or less similar and which were not always able to overcome the increasingly difficult demands of natural selection. Some of those lines perished and others survived. The ones that survived were the hominid groups that were most adept at using tools and therefore more intelligent. All of these waves of migrating hominids consisted of small groups which, despite the fact that they used tools and brandished rudimentary weapons for hunting, had not yet developed the sufficient sophistication of a hierarchical society per se. These early hominid groups began migrating away from their original areas about 2 million years ago and did not stop migrating until about 50,000 years ago. All of them had essentially the same characteristics, but over time would develop unique traits as well. With each evolutionary step, the genealogy of mankind was becoming more and more complex. At present, humans are the only intelligent species on Earth, but that was not always the case. From the moment hominids started evolving in Africa, there were many species that exhibited what we tend to call intelligence. Some of them became extinct. In their place, other species appeared. Some species shared the same territory, and it is generally thought likely that the best prepared species wiped out their weaker competition. This was very possibly the case of Afarensis and Ramidus about 4 million years ago, and more recently between Homo sapiens and Neanderthals, which occurred just 40,000 years ago. In fact, that was probably the last time one intelligent species wiped out another intelligent species. We do not know if these conflicts were solved in battle or by means of subtler struggles fought for supremacy over territory or scarce resources. Fossil studies have yet to determine whether Homo sapiens actually deliberately killed Neanderthals, or if they were simply more skilled in controlling their environment thanks to more sophisticated technology. From among all these evolutionary hypotheses, no direct line yet links modern man irrefutably with early hominids. In fact, human evolution looks more like a whimsical maze of paths that we do not fully understand. The Atapuerca Mountains, some 15 kilometers east of the Spanish city of Burgos. This was on the medieval Way of Santiago, which brought pilgrims from all over Europe to the Galician burial place of St. James the Elder, and also the site where Europe's oldest vestiges of early human communities are. In this land, some 800,000 years ago, there lived a distant relative of ours, something like a great-granduncle of present-day humans. The site's discoverers called this relative of ours Homo antecessor, or predecessor.
Up until the discovery of Homo antecessor in the fossil field of Gran de Lima, we had the idea that Europe was a continent populated much more recently than Asia, and of course Africa, the cradle of mankind. It was thought that human beings had not settled in Europe until about 500,000 years ago. Neanderthals and humans are closely related species, practically kin, but which began to significantly differentiate at some point in time. Atapuerca has also proved that our evolution became independent around 500,000 years ago. The Gran de Lima fossil field, dating from 800,000 years ago, that is some 300,000 years before this differentiating division began, suggests that these fossils do not belong to any of these two lines, neither Neanderthals nor modern humans, but to the common trunk that later split.
In Atapuerca, there are also remains of a group of hominids that lived around 300,000 years ago, the Homo heidelbergensis. These beings had a larger cranial capacity than ours, but their manual skills were much less dexterous. With regard to cultural aspects, they had developed some advanced customs, such as burying their dead and spiritually oriented rituals. If Homo antecessor is a kind of granduncle, Homo heidelbergensis was a direct uncle, living as he did in the mountains of Atapuerca. His most direct evolutionary heir was the unfortunate Neanderthal man, the last intelligent species to become extinct. Neanderthals, classified now as Homo sapiens neanderthalensis, was a contemporary inhabitant of Europe at the time of our most direct ancestor, Cro-Magnon man. Neanderthals evolved in Europe over hundreds of thousands of years. They were able to make tools and to use them skillfully. They communicated and had burial rites. They were actually just as human as we were, but their physical aspect was somewhat different. If we could bring back a Neanderthal man today and dress him like us, he would still draw attention no matter where he went in the world. Conflicts between Neanderthals and Cro-Magnons probably lasted for a long, long time, and only ceased when Neanderthals died out some 30,000 years ago. Their enemies, our direct ancestors, had simply prevailed over them. They had better tools and had created certain symbolic systems that allowed them to remain united and ultimately to survive. The conflict between Neanderthals and Cro-Magnons was not a military conflict. It was more like a competitive ecological struggle between species that practically relied on the same level of intellectual resources. Such a displacement of one species by another without violence is not an unknown phenomenon to biologists, for example. After competing for the same resources over thousands of years, Cro-Magnons simply took over the environment little by little. Over such a long period of time, Neanderthals were almost certainly not fully aware of their species' decline from one generation to the next. The world they came to was not so different from the world they left behind, but they realized that they were suddenly competing with another species. Little by little, Neanderthal groups broke up. They moved to other less productive areas, and their birth rate fell. When Neanderthal groups broke up, they lost contact and the ability to intercommunicate. This and their resultant isolation is thought to have been responsible for their extinction as a species. This newborn baby girl will inherit many of her physical features from her parents. The color of her eyes, skin, and hair will be determined by her progenitor's genetic traits. She will develop and grow up to be of a certain height. One day, around about the year 2030, she will become a mother, and her child will grow to maturity around the middle of the 21st century. This child, of course, will probably have children too, and if things turn out right, our original little baby girl will see her first grandchild around 2075. It's also entirely likely that one day, near the beginning of the 22nd century, she will be able to cradle one of her great-grandchildren. However, if we go back in time, where would the other end of the chain be? In other words, who would be the first female to give birth to the first Homo sapien? The development of biogenetics has been of tremendous help in unlocking the key to mankind's evolutionary process. The most revealing contribution was the so-called theory of Black Eve, which was the result of studies made at the University of California at Berkeley in 1986. The Black Eve theory states that all human beings alive today came from a common ancestor, a female that lived in Africa around 150,000 years ago. This conclusion was reached on the strength of results from several studies on mitochondrial DNA, a type of DNA that resides not in the nucleus of a cell, but in a cell's mitochondria. Only females can transmit mitochondrial DNA to their offspring. This allows scientists to trace genetic lines backwards in time to what has been defined as our common ancestor, the mother of all Homo sapiens. The different varieties of human beings, commonly known as races, have only appeared in the last 150,000 years as humans adapted to different environments. Skin color, body size, and hair types are features that developed over time through the process of evolution. Actually, there are no significant differences among the so-called races, and we probably shouldn't even use the term. The truth is, the concept of race is a cultural anachronism used by certain social groups to justify distinctions that really do not exist.
The term race is unacceptable in science, and technically speaking, it cannot really be applied to humans. It is a term for veterinarians or for farmers. You cannot talk about human races as you talk about the different breeds of dogs or cats or other pets or animals. One main reason for this is because our species is the least heterogeneous species among mammals. Ours is a species with very little genetic diversity. All human populations are practically identical. Every human being is practically the same from a genetic point of view. Obviously, there are superficial differences, striking differences even, in skin color, hair type, and other external features. But really, those differences are the results of very minor genetic differentiation.
From the perspective of our modest understanding of the concept of time, we found that natural selection works very slowly. However, that's not the case with the changes man has made to his environment since the time human intelligence began working at its current level. Humans who lived 100,000 years ago did not live that remarkably differently from humans who lived 2 million years ago. However, we only needed a brief 40,000 years to reach the moon, to compose great symphonies, and to clone living beings. Many scientists believe the catalyst and motor of such dizzying human achievement has been our ability to speak. Around 100,000 years ago, the humans who would eventually change the world migrated out of Africa. Until then, the differences between the people who migrated and those who stayed behind were essentially insignificant. Those who left may have somehow surpassed the others and thus prevailed over them. The secret of that supremacy was very possibly their ability to speak. A minute genetic change, a very slight DNA mutation, reshaped these hominids' larynx, tongue, and certain muscles. These, of course, are the physical prerequisites for speech and language. We humans reinvent our world every day thanks to language. The culture we have created, the knowledge we have accumulated over the centuries, and the technologies that improve our lives on a daily basis are basically expressions of the practical applications of language. Language is inconceivable on an individual level. It is only meaningful when used within a group. Language is therefore a social heritage. In fact, we humans might be thought of as merely complex data processors and transmission units. The ability to exchange information among individuals or between different generations gives mankind a group identity that has facilitated our passage through evolution. It's more than likely that this amazing feature was the key, some 30,000 years ago, to the prevalence of Homo sapiens over Neanderthals. And of course, it will continue to be the engine that drives man's dominance over the next several thousand years. What are we going to be like in the future? Will we have a larger head than we do now because our brain will be bigger? Or will our legs be shorter because of all the automatic features of future locomotion? Will our teeth disappear if we eat only concentrated food? There may come the day when we actually create our own version of human beings. Or maybe we'll create, as many prominent writers of science fiction have suggested, beings who are half human and half machine. There is certainly a wealth of fascinating ideas on the matter. Perhaps it was Aldous Huxley who, in his 1932 novel, A Brave New World, imagined the most feasible future reality for mankind. The plot describes a future world inhabited by beings genetically programmed to accept the role their society sets out for them. It's a frightening scenario in which freedom is on the fringes of organized civilization. For the time being, Huxley's sad world remains a harmless fantasy, but the possibility of manipulating the genome of living beings is certainly a shocking reality. According to Stephen Hawking, arguably the most famous living scientist in the world, mankind started controlling our evolution the day the sheep Dolly, the first cloned mammal, was born. From that moment on, the possibility of duplicating humans was just a question of time. Biogenetics is, in fact, one of the factors that will most affect how we define our immediate future. We can foresee some of the consequences, but others that we are not even able to imagine will undoubtedly occur. We already know how to predict the advent of diseases before they actually develop, and very soon we'll most probably have the means to prevent them as we live better, longer, more productive lives. The heart was the first human organ replaced with a man-made device. It's also true that the heart is the human organ that most often fails. However, recent experiments in bionics suggest that extremely practical solutions may be available in the very near future. In fact, at this point in time, it's practically inconceivable that there might exist a bodily dysfunction that will not lend itself to a bionic solution in the near future. Patients who today can only submit to uncomfortable dialysis treatments will have man-made kidneys that will unquestionably improve their quality of life. Among the most imminent bionic solutions are lungs, muscles, and capillary arteries that in a few years will be common. But the greatest challenge posed by bionics is designing devices to repair the senses, such as hearing or sight. Right now, there are man-made systems that can supply approximately 10 or 15% of a blind person's sight. But for now, these devices have only been successful in laboratory experiments. Designer babies, bionic men and women. The future of the human species certainly looks long and prosperous. We might improve our looks, we might live healthier lives, and we might live a whole lot longer. But will we become more intelligent? If we had asked that question 40,000 years ago, the answer might have been the same as it is today. Back then, our ancestors lived in caves and made stone weapons and tools. Today, we design intelligent buildings, use computers, and make missiles. But the origin of it all is in our brains. It is the same brain we had 40,000 years ago, and it will probably be the same brain we have 40,000 years from now. The fact is, it's not likely that natural selection is going to change us into smarter beings. The answer, once again, is somewhere inside us.
Intelligence or any other function is an interaction between genes and environment. And so, in fact, it's a somewhat less known fact that the average IQ has been increasing steadily for the last 100 years, ever since they started measuring it. But it is always normalized to the average in the population. So what does that mean? That does not necessarily mean genetic evolution, just too short a time frame. But as our environment changes and our ability to educate children and provide new stimuli continues, there will be continuing changes. There can be improvements or not improvements depending on the situation and how you look upon it, actually.
Intelligence, a slow and detailed coincidence of nature that has allowed man to become lord and master of all that he sees. Despite the rampant social inequalities man has created within his own species, human beings in general have increased their life expectancy to remarkable lengths. We are such a plentiful species that we can practically inhabit any place on this planet, no matter how adverse the conditions. In order to establish and maintain this hegemony, we have naturally had to transform the world. And now we are not sure how the alterations we have made are going to affect our future. The ultimate purpose of any living species is to survive over time. Experts say that the average existence for any species is around 4 million years. Man is not even 200,000 years old yet. It's possible that the amazing mechanisms that came into effect some 6 million years ago and gave rise to human intelligence are now turning against us. We do not know very much about how we will evolve in the future. It's possible that the same intelligence that has defined us and helped us up until now will actually be the instrument of our ultimate demise, and that might come sooner than we think. Perhaps someplace in Africa, the species that will replace us is already well on the evolutionary road of development. There might be some kind of amazing mutation, like the one that gave man speech. It might be a mutation that could instill in some other species a powerful quality that we cannot even imagine. But then again, maybe we shouldn't be looking at Africa per se. Maybe we should consider the world's most advanced laboratories, where new human beings are being made. Humans with telepathy or other powers hidden in the areas of the brain that we simply have yet to control. They might be people who look just like us and go unnoticed amongst us for a long, long time.